Okay, I'm gonna start, guys. So first, I'm assuming you guys did these problems, but I'm still gonna go over the problems with you guys. So we're gonna read the problem once. Basically, I'm gonna give an explanation of what the problem is, and then we'll go into how to code the thing. So the first problem was sleepy cow sorting. Farmer John is attempting to sort his N cows, conveniently numbered 1 through N, before they head out to the pastures for breakfast. Currently, the cows are standing in a line in the order P1, P2, P3, all the way to Pn, and Farmer John is standing in front of cow P1. He wants to reorder the cows so that they are in the order 1, 2, 3, all the way up to N, with cow 1 next to Farmer John. The cows are a bit sleepy today, so at any point in time, the only cow who is paying attention to Farmer John's instruction is the cow directly facing Farmer John. In one time step, he can instruct this cow to move k paces down the line, for any k in the range 1 through n minus 1. The k cows whom she passes will amble forward, making room for her to insert herself in the line after them. For example, suppose that n equals 4, and the cows start off in the following order. The only cow paying attention to Farmer John is cow 4. If he instructs her to move 2 paces down the line, the order will subsequently look like this. Now, the only cow paying attention to Farmer John is 3. So in the second time step, he may give cow 3 an instruction and so forth until the cows are sorted. And basically, the input is going to give you n and then n number of integers that are giving you the starting order of cows. And then a single integer you have to output to show how many times you have to change to sort them. So I'm going to go off based on this, the original 4. The sample input they gave 4 and 1, 2, 4, 3. So we know Farmer John is right next to cow 1 at this point. But we need to order this, so we know inevitably 1 and 2 have to move. So if we were to do this by raw calculation, we put 1 behind 4, that's 1 time step. We put 2 behind 1, which is going to be right here. And then we're going to move 4 all the way to the end, which means there's 3 steps. But however, instead of doing this manually, because that will take a very long time and USACO does have a time constraint, we want to find a much more efficient way. So we know that this is out of order, usually, most likely. So what we're actually going to check is that if the number we are on is smaller than the one before it, that means there's going to be the amount of times the sorting, or what we know as the, what is it called? Time steps will take. Because why does that work? So I'm going to use that same logic I just used. We're going to start from the back for this case, since we need to check the one before it. 3. If 3 is smaller than 4, then the answer is going to be 3. Why is that? Because we start at n minus 1. Because I hope you guys all know, indexes start at 0 and go up to n minus 1, even if the length is n. So we know this is n minus 1, and we know this is n minus 2. However, we know that this is smaller than this, so n minus 1 is going to inevitably be 3. So by that same logic, we're going to have to code there, right? So we see here, I made the basic format already. I hope you guys have that. Use scanner, yada, yada, yada. So we're going to be given n and an array that has n integers. So static int n for n. And since we need an array to hold all the integers, static int a. And we need to fill this array up after initializing. So n equals n dot next int. And then we got to initialize a. And then for the next one, We're gonna keep on using in.next int, so we don't need to put it in.next to clarify, because since we're only using in.next int, and we're gonna use a for loop for this. And a at I go with in.next. And what I suggest you guys always do is check if what you're putting into the array is correct at the moment. So we're going to write system.out arrays. And I already filled in sleepy in and sleepy out, so that shouldn't matter. And if we run it, what we should get is 1, 2, 4, 3 as it came out. I do suggest trying, like, making sure you don't mess up in the middle, because there's a lot of times where you will waste a lot of time trying to find that small detail that was in the beginning. So, like I stated before, we're going to go by the logic that if the current index we are on is smaller than the one before, that means that's the amount of times we need to sort. So we're going to make a starting variable int ans for answer. And from there, we're going to have to run a for loop to make sure to, like, find where it's smaller, right? So we start at n-1 because, like I explained before, the last index is always n-1. I is greater than 0, because we don't want to get to the last one, considering we have to check the one before I minus minus. So if a at I minus 1 is greater than a at I, basically if the number before it is bigger, and equals I, and then you break. Why do we break here? Because once you find how many times we have to sort, you don't have a need to find it any much more longer. So you just break out of it, and then you just put out the println ans. And if you were to run that, it should come out as 3. I already submitted it before, as you can tell, and it was right. Does anyone have any questions right now? I did do that kind of quickly because it wasn't that much of, like, very confusing question. So does anyone have any questions? If you do, please just leave it in the chat. I don't mind. So before I move on to the next question, which is going to be guess the animal, I'm going to explain my logic one more time for these kind of questions. So we're giving n amount of integers, right? And we need to find out how many times we have to sort it. And we know only the first cal can move. Knowing that, we know we have to find how many times we're going to have to move the first cal to the back and to the back and to the back, like we did 1 behind 4, 2 behind the 1, and then yada yada. I'll show that with an annotation to show the logic. Since it's 1, 2, 4, 3, we want to order this in the minimum amount of possible. So we're going to move 2, 4, 1, 3, because we cannot move the 4, because all we really need to move is the 4, however. So we make 4, 1, 3, and we move the 4 all the way to the back. So it's like this. To do this, we know 4 is out of order, right? So we need to find that one thing that is out of order clearly. And that many numbers is going to be the numbers that we have to move. So by that same logic, we just need to find that one number where the number before it is bigger than the index it is currently at. So by that logic, we just continue to look at the one in front, right in front, and we check if that's bigger or smaller. And so that was Sleepy Cow. Do we have any questions about what I just explained? I know like 1 or 2 of you came late, so I don't blame you. All right. If no one has any more questions, we'll move on to the next one, called Guess the Animal. Like I did before, I'm going to start by reading the question. When bored of playing their usual shell game, Bessie the cow and her friend Elsie like to play another common game called Guess the Animal. Initially, Bessie thinks of some animal. Most of the time, this animal is a cow. I don't need to read that. Then Elsie proceeds to ask a series of questions to figure out what animal Bessie has selected. Each question asks whether the animal has some specific characteristic, and Bessie answers each question yes or no. For example, does the animal fly? No. Does the animal eat grass? Yes. Does the animal make milk? Yes. Does the animal go moo? Yes. In that case, I think the animal is a cow. Correct. So basically, it's 20 questions. If we call the feasible set the set of all animal characteristics consistent with Elsie's questions so far, then Elsie keeps asking questions until the feasible set contains only one animal, after which she announces this animal as her answer. In each question, Elsie picks a characteristic of some animal in the feasible set. She never asks about the same characteristic twice. Given all of this, Bessie and Elsie know as well as characteristics. Please determine the maximum number of yes answers Elsie could possibly receive. So basically, they're trying to find how many times, what is the maximum number of times Elsie has to ask a question to find out which animal it is. So the import format would be n. The next n lines will be given the name of the animal, an integer listing how many characteristics there are, and then the characteristics. And it says here you're guaranteed that no two animals will have the same characteristics. That does not mean you can't have eats grass together. It means you can't be sheep one eats grass and makes milk, and goat two can't be the same. And basically you have to output the maximum number of yeses. For this, we're gonna do a little bit of manual labor before we start. So we're given 4 different animals. Bird, which has characters of flies and eats worm. Cow, 4 characteristics, eats grass, is awesome, makes milk, goes moo. Sheep, only has 1 characteristic, eats grass. And goat 2, makes milk, eats grass. So if we look at all these characteristics, which character comes out the most? If you said eats grass, that's correct. So we see that eats grass appears 3 out of the 4 animals. There is no other trait that appears that many times. So what we're going to do is we're going to continuously look for the trait that appears the most amount of times, because we want to get the maximum number of yes. So we're going to eliminate bird since eats grass is only here. So the next trait that we want to know that comes out the most is makes milk, because eats grass, we've already checked that one. So that one is common throughout. Is awesome only appears here. Goes moo only appears here. So makes milk appears twice, so we can eliminate sheep. That's 2 yeses. Now, if we can't do eats grass or makes milk, we know it's either going to be is awesome or goes moo. But we don't need to ask both of those questions to make sure if it's a cow or not. We just need to know one of these two. So we can eliminate goat, assuming that our answer is cow. Then we have to ask a maximum of 3 questions. Let's take the case where we don't ask that order of question. Let's say we ask some other question. Let's say we start with makes milk. If we ask, does it make milk? Then we can eliminate 2 from that initial set already. And then if we ask another question, is awesome, it eliminates it in 2 steps, but we're trying to find the maximum. So knowing that, let's start coding. I set up everything ahead of time. I hope you guys did the problem as well. So this one's a pretty long one. So what do we know? We're given n, name, number, and characteristics. We're gonna start with n, that int n, and we're gonna initialize that. And what we're gonna do here actually was we're gonna go out on a limb and make a hash set. I'll explain further why I made an array of hash sets very soon. As soon as I initialize it, I will show you why that makes sense. And we're going to initialize it here, equals new hash set n. And why did I not do excuse me, in the next as soon as I saw in the next int, because when I initialize the a for the hash set, int I equals 0, I is less than n, plus plus. So what we're gonna do is we're gonna individually initialize each and every hash set within the array. So I is equal to new hash set string, because it's going to hold the characteristics. These characteristics we need to be unique. Hash set will only hold values that are unique, not overlapping. So that's what we kind of need right now. So we just put a hash set, and then we're going to put indent_next in here. In fact, it'll be clear why we put the indent_next in there right now soon. Int m is equal to indent_next int, because we put another indent_next int, unfortunately, and then we put while m minus minus is, I'm gonna put a space here so it's not confusing. It's not m arrow, it's m minus minus is greater than 0, and I is dot add indent_next. So indent_next is literally just adding in the characteristics. We're gonna print that out. String. And if we print that out, yes, we'll get each individual characteristic of each animal in like this. We know birds with flies eats worm, cows makes milk, is awesome, goes moo, eats grass. The other ones eats grass and makes milk and eat grass. So we know the array is working fine. Is anyone confused as to why I use the hash set? Just to clarify, I'm going to explain one more time. A hash set basically input takes in things, but it doesn't take in repeats. Basically, if it were an integer hash set, let's say I put a 1 and then a 1, then it'll only keep 1, 1. And that's what we kind of want here, because even if there's overlapping characteristics, we don't want that. We just want one of them. And plus, hash set is much faster. So now that we are initialized everything, we need to find the maximum times something appears by counting. Int max equals 0. Max will change for int I is equal to 0. I is less than n, because we want to go through the entire, basically this thing, the characteristics list. Because what we're basically going to do this for loop is we're going to make another nested for loop, and we're going to examine how many times does this appear over there. If it appears a lot, add 1 to a count variable that we will initialize soon. For int j is I plus 1. We want to start in front of I, not 0 all the time, because if we start at 0, it's going to count, make some overlaps. J is less than and minus 1, because you have to add I 1 to I, and n can be that big. No, I switch it around. Since I can, you add 1 to I and j, we make j go all the way, but I only go to n plus 1, j plus plus. Go down here. So here, before we start anything, we will make count variable. But we're going to start at 1, because we know the characteristic that we're examining always exists within the characteristic set that we're starting with, because there's no way we can check if it exists if it never existed. So we know count starts at 1 no matter what. Then we're gonna go out on a limb, string s a at j. I mean, not j, I. So what is this? So s will hold each characteristic within a at I, which in this case happens to be flies or eats worms. So what we're going to do is if a at j that contains s count plus plus. So what are we doing here? We're counting the amount of times we have to ask a question, basically. So by this logic, to put it simply, flies. we get flies first. So we then look through each and every hash set within this hash set array. We look, is there flies? If there isn't, don't add. If there is, add one. But we see that flies is not there. So we don't do that. We look for eat swarms. It doesn't exist. So we know CNT doesn't do anything, and we know count is still 1. And then from there, we check. Max is equal to math.max max and CNT. If you see here, CNT will give you an error. I hope you did notice that because it's outside of where I created CNT as a variable. So we put it back in here. And then for that, it'll check if count works or does not work. And then we're going to print out count. So, oh, not count, I meant max. Oh, okay. Anyways, so I'm going to explain the logic, what happens one more time. Flies, checks everything, nothing. So count doesn't change. Eat swarm, checks everything, doesn't appear. Makes milk, appears as we see here. No, we don't want to check. Makes milk appears twice. Is that bigger than max? Yes, that's 2. Is awesome, is only 1. 1 is not bigger than 2. Goes milk, smaller than 1. Smaller than 2 because it only appears once, so it's still 2. Eats grass, appears 3 times, so max becomes 3. And then now we move here. We go here, eats grass, appears twice, still smaller than 3. Go here, it's going to be 1 no matter what because there's nothing after it. So the max will ultimately end up as 3. Okay. And if we print that out, it should give us 3 by that, because we just coded this computer to do what we want. Basically you guys probably heard this a lot. You just got to make the computer think the way you think to solve problems, and it'll most likely do what you want, unless you made an error in the middle or not. So, does anyone have any questions? No questions, absolutely no questions. All right, I guess then I'm going to explain this problem one more time, and then we'll see from there. So this problem is basically 20 questions, like I said before. And what we want to find is the number of times we have to ask a question, the maximum number of times we have to ask a question, and that question's answer has to be yes, not a no. So we're given n names of the animal, how many characteristics, and what is it called? The characteristics itself. So we got n, and we made a hash set array. So why we made a hash set array? Because we have several lines of characteristics, so each one is going to be a different hash set. And the reason we use the hash set is because 1, it's fast, and because if we were to make an array of array lists, that would take much more time. And also hash sets ensure that you do not input repeats. So knowing that, we initialize it. We make hash set n, we put next, and we make sure we put and not next. So we skip the name, we make m the number of characteristic it is, and then while m minus minus is greater than 0, we continue to add a characteristic. And once it runs out, bam. So knowing this, we need to find the maximum of times we want to say yes. So we find variable max. And then we make this nested for. I only goes up to n minus 1 because j goes I plus 1. And with that logic, j will go all the way up to n. Because what we're doing basically is we're starting at that integer and we're comparing to everything after it. And basically we go all the way to the end, next one, yada, yada, yada. And we make a count variable, count being counting how many times we ask a question. So we write string s. holds everything within A of I. I'm gonna make A appear again. And so S will be flies first, checks everything. Flies doesn't appear. Worms checks everything, only appears once. The count will be 1. Next, we check, is 1 bigger than 0? Yes. If it is yes, go on, move on. And we go on to the next I, which is going to be makes milk is awesome, goes yada yada yada. And then what we do is string S, we'll check, is there mixed milk? Since there is a mixed milk, it'll add 1 to count. Is awesome, doesn't add anything. Goes moo, doesn't add anything, eats grass, we'll add 3. So count will become 5. So max will be 5 this time, right? We go to, no, not max will not be 5, max will be 3. My bad. Because if it does contain anywhere, it just adds 1. That is my bad. Go to the eat grass, contains it once, so it's 1. Makes milk. Yeah, it doesn't appear anywhere else because that's the last integer. So we know the max was 3. We print out max. And you should get 3 from that. And I submitted it before class, so it should give you all the answers. We ended very early. I finished very early. Do you guys have any questions? Because I did go relatively fast. If there was any part that was confusing, or like you want to get a deeper explanation about, please, you can privately chat to me through Zoom. I don't mind. It is my first time taking USACO, so I want to make sure I'm covering all the bases here. Does anyone have any questions? Any questions at all? It doesn't matter, anything. Okay. All right. If there is no other questions, I will end class early. But I want you guys to know, there will be more problems for tomorrow. I want you guys to solve this before class. I feel like what I want you guys to know is that solving the questions before class is actually an important thing because it helps get your brain warmed up. It helps you actually think and basically work out your brain and know what you're doing. And if you just rely on like the answers that I'll give, then you probably won't learn a lot. And if you guys really do want to get bronze, I do suggest practicing a lot on your own. And if there's nothing else, you guys are free to leave. And if you guys have any questions outside of class, feel free to DM me on Discord. I'll try my best to answer it. It probably won't be the best, but still. All right, then thank you, everybody, and have a wonderful night. Yes, please do solve it.